that by considering the minimum and maximum value of cosine function, and the cosine function is going to be this cosine 3 to the power of n plus 1x. So let me just write down here, okay? I will be starting with this later also. Cosine 3 to the power of n plus 1x. So what is the minimum and maximum of this? It is from -1 to 1. Okay, so this is how I will be starting my question. I will be dividing this by -3 to the power of n plus 1 throughout. -3 to the power of n plus 1. -3 to the power of n plus 1. And it is this -3 to the power of n plus 1 that has a problem. Okay, I'm going to let n be equal to 1, let n be equal to 2, and so on. So when n is equal to 1, we have a -3 to the power of 2, which is going to be equal to 3 to the power of 2. When n is equal to 2, we have a -3 to the power of 3, which is a -3 to the power of 3. When n is equal to 4, we have a -3 to the power, sorry, n is equal to 3, this to the power of 4, this is going to be positive 3 to the power of 4. When n is equal to 4, then we have a -3 to the power of 5, we have a -3 to the power of 5. So it is not the 3 to the power of that is the pattern that I'm trying to catch. The pattern that I'm catching now, right, is the fact that it is plus, minus, plus, minus. Plus, minus, plus, minus. That is how EJC has set up a question that is like this, because we are not dealing with an equation, we are dealing with an inequality. Because we are dealing with an inequality, and -3 to the power of n plus 1, when n are positive integers, n can be changing. Sometimes it can be positive, sometimes it can be negative. So I cannot just simply divide it and expect myself to get a consistent result. So I have no choice. I have no choice but to remove this, because I'm unable to make that decision, okay, whether I need to swap the inequality sign or not. So I think I'm going to try to analyze based on when n plus 1 is even. Then another case will be when n plus 1 is odd. So let me analyze these two cases, okay? N plus 1 is even. The other one is when n plus 1 is odd. Of course, like what we were saying, we can also try to say even as I'll let n plus 1 be equal to 2k. And it is important for me to highlight that k are integer values. Because if it is 2k, if k is real numbers, right, I'm not trying to come up with a form of even numbers also. So this can also be n plus 1 is equal to 2k plus 1. Or I can also say that it is 2k minus 1. Either or, I just need to write one of them. It's good enough. Where k are integer values. In this case, I'm going to go for a positive integer because n is a positive integer. -3 to the power of n plus 1 is going to be a positive number all the time when n plus 1 is even. Which means that I can just simply divide this entire thing, cosine 3 to the power of n plus 1 x. I will divide this by -3 to the power of n plus 1 throughout the inequality, and nothing changes. So -3 to the power of n plus 1. This is less than or equal to 1 over -3 to the power of n plus 1. Okay? And this sort of like synchronized to this. If we are dealing with an inequality that looks like this, where if I were to just compare this to what the question says, right, it seems to be suggesting that fn is equal to -3 to the power of n plus 1, and p is equal to -1, and q is equal to 1. Okay, based on just what I've written here so far. Okay, so if I can synchronize it to the hints that is given to me by the question in order for me to apply this squeeze theorem, right, then maybe I can then argue that the limit of this is equal to 0. Let's try it. Let's list down the version that is here first. Okay, because the version that is here is going to be a little bit problematic, because we are not just trying to discuss for certain values of n. We are trying to discuss for all integer value, for all positive integer values of n. So for this that is here, we have a -3 to the power of n plus 1. This is supposed to be less than 0, according to what we saw just now, right, when n plus 1 is odd, minus number to the power of odd is going to be a negative number. So when it is less than 0, and the reason why we are interested in bigger than 0 and less than 0 is because we are trying to divide this term across an inequality. So in a way, I guess this question is testing us on inequality also. Minus 3 to the power of n plus 1. Then we have a minus 1 divided by minus 3 to the power of n plus 1. We have a 1 over minus 3 to the power of n plus 1. So since I'm dividing something throughout this inequality by negative, so the inequality sign here must swap. So now it is swap. Not correct lah. Okay, I don't think it is correct, because if I were to try to make this look like this, right, then we are looking at cosine 3 to the power of n plus 1 x over minus 3 to the power of n plus 1 is supposed to be bigger than this, bigger or equal to this. So bigger or equal to 1 over minus 3 to the power of n plus 1. It is supposed to be less than or equal to this. So this is supposed to be less than or equal to minus 1 over minus 3 to the power of n plus 1. So this is not very correct, because looking at this, it seems to be suggesting that Fn is this minus 3 to the power of n plus 1, which is the same as this, but P seems to be equal to positive 1, here is negative 1, and then Q here is minus 1. So this is not correct. Is there some other things that we can try to do in order for me to synchronize these two results? And this becomes, to me, becomes more and more difficult, because the boundary becomes less and less obvious. That's why I find this question difficult to do in an exam. Anyone has any suggestion how we can synchronize these two results? Okay. What if I were to do this? I factorize out this minus 1 to the power of n plus 1. Then we will have a 3 to the power of n plus 1. This I'm going to leave it as it is. I'm not going to touch this n plus 1 x divided by minus 3 to the power of n plus 1 less than or equal to, I'm also going to factorize out this minus 1 to the power of n plus 1, then 3 to the power of n plus 1. And this minus 1 is also a good number when I do a power of it, because it's easier as compared to all the other numbers. So what is minus 1 to the power of an even number? It is going to be positive 1, correct? So I'll be getting a minus 1 over 3 to the power of n plus 1. This is going to be cosine of 3 to the power of n plus 1 x over minus 3 to the power of n plus 1. And we will have a 1 over 3 to the power of n plus 1, because minus 1 to the power of an even number is positive. Similarly, what if I were to have a minus 1 to the power of an odd number? So we have this, n plus 1, 1. So this is here, cosine of 3 to the power of n plus 1 x over minus 3 to the power of n plus 1. Then we have a minus 1 over minus 1 to the power of an odd number, because n plus 1 is an odd number. Then 3 to the power of n plus 1, which will leave me with a n plus 1, minus 1 to the power of odd number, minus 1. So I have a minus 1 over 3 to the power of n plus 1. I don't have to touch the inequality because I didn't multiply throughout. It is just this expression by itself. So I can maintain this as it is, n plus 1 x over minus 3 to the power of n plus 1. This is less than or equal to minus 1 minus 1, you become positive 3 to the power of n plus 1. So now this and this synchronize. What I have just proven is that for all integer values of n, not just even or odd, for all integer values of n, this is true. It is synchronized. Correct? So I can now say that since, okay, I'm going to conclude this, okay? Since we see that this cosine 3 to the power of n plus 1 x, I'm going to just recite this statement, Squeeze Theorem. Okay, but I fill in the information. If you have been reading the question a few times, right? As you fill in the information, you will see the logic that is behind. Then you know that you have understood, the question. You have learned through the question which is trying to teach you on the spot. So this over minus 3 to the power of n plus 1. Since this, we have just discovered that it is always going to be between minus 1 over 3 to the power of n plus 1 and positive 1 over 3 to the power of n plus 1 for or a positive integer n, for all positive integers n. And we can also see that the limit when n tends to infinity of this minus 1 over 3 to the power of n plus 1. What is this going to be when n tends to infinity? 0. And I can also see that the limit when n tends to infinity of this, which is 1 over 3 to the power of n plus 1, all this will become 0. Okay, that means this is squeezed between two numbers that will become 0 when n tends to infinity. So therefore, limit, okay, then I will use the word then. Then limit when n tends to infinity of this cosine 3 to the power of n plus 1 x over minus 3 to the power of n plus 1 will become 0 by the squeeze theorem.